Write the sum using sigma notation. To write a sum using sigma notation, we need to know how many terms are in the sum, and then also determine a formula that will generate the terms in the sum. Analyzing the first sum, we can see we're adding 5 fractions, and analyzing the numerators and denominators, notice the numerators are all 2. Looking at the denominators, we might notice that 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and so on. But also remember we can write repeated multiplication using exponents. Notice 3 is equal to 3 to the first, 9 is equal to 3 squared, 27 is equal to 3 cubed, 81 equals 3 to the fourth, and 243 is equal to 3 to the fifth. This indicates we can write the sum using sigma notation, where we have sigma, and the formula is going to be 2 divided by 3 to the power of n, where n, the index, will start at n equals 1 and end at n equals 5. And now let's look at the second example. Our goal here is to write sigma notation for the sum, but notice here we're alternating between subtraction and addition. And therefore it's important to recognize minus 8 is equivalent to plus negative 8. So we could write this as 4 plus negative 8 plus 12 plus the next number would be negative plus dot 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 all the way out to plus 60. So we can think of this as a sum, it's just that the terms alternate sign. Before we consider the given sum, let's determine the formula if we were adding all positives. So let's consider 4 plus 8 plus 12 plus dot 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 plus 60. Again, I know this is not the given series, but this will help us build the formula for the given series. We might recognize that 4 plus 4 is equal to 8, 8 plus 4 is 12, and so on. But also notice that 4 is equal to 4 times 1, 8 is equal to 4 times 2, 12 is equal to 4 times 3, and then going out to 60, 60 is equal to 4 times 15. Recognizing this pattern, we now know there are 15 terms in the sum. Sigma notation for the green sum would be the sum of just 4n from n equals 1 to 15. But again, this is not the given sum. We have a sum where the terms alternate sign. And therefore we can adjust this formula by including a factor of negative 1 to the power of n plus 1. So the given sum would be the sum of negative 1 to the power of not n but n plus 1 times 4n from n equals 1 to 15. Let's talk about why I included an exponent of n plus 1 instead of n. This is because the first term is positive 4, and notice when n equals 1, the exponent on negative 1 would be 2, and the square of negative 1 is positive 1, giving us positive 1 times 4 times 1, or positive 4. And then when n is 2, we'd have plus negative 1 to the power of 3, which would be negative 1 times 4 times 2, or times 8, which would give us plus the negative 8 that we need. So this is the correct sigma notation for the original given sum, which again alternated between subtraction and addition, which we can always write as a sum as shown above. I hope you found this helpful.